Welcome to Honors Chemistry. I'm Mrs. G. This first lesson is meant to be a review in measurement techniques. Measurement in chemistry is extremely important. We have to remember that measurement is never perfect. It always requires some degree of estimation. For instance, if I asked you how long the first pencil in the picture is, you would say somewhere between 6 and 7 centimeters long. Some of you might say 6.5, some might say 6.7, some might say 6.8. We're sure that the pencil is longer than 6 centimeters. We're sure that it isn't quite 7 centimeters, but beyond that, we're going to estimate. Even digital machines estimate. For instance, if you got on the scale this morning and you weighed 132.6 pounds, that 0.6 is estimated. Your scale automatically registers 0.6 if your weight is anywhere between 132.55 and 132.64. If your weight is 132.65, it is going to automatically bump the point up to 0.7 instead of 0.6. So, in chemistry, we use metric units to measure, always. We never ever use English measurement. We don't use inches, we don't use feet, we don't use pounds. In fact, most of the time in chemistry, we use special metric units called SI approved units. SI stands for System International. It's a specially approved system by an international council that meets from time to time and decides on which units would be appropriate for everyone in the world to use. The official SI unit for length is the meter. The abbreviation for meter is a lowercase m. In the photo, there is a meter stick, or at least a portion of a meter stick. You can see that there are smaller units within the meter stick. A centimeter between the 6 and 7, which is 1/100th of a meter, and a millimeter between the 90.9 and the 91, and that represents 1,000th of a meter. The official SI unit to measure mass is the kilogram. The abbreviation for kilogram is kg. In this course, we usually don't weigh things as heavy as a kilogram. We often use the kilogram's smaller relative, the gram. You can see the paper clip in the bottom right corner that weighs about a gram. The SI unit to measure time is the second. That's a lowercase s, not SEC. Of course, we also use the minute and the hour. The SI unit for temperature is the Kelvin. That's a capital K. However, because the numbers are so large in Kelvin, in the lab, we generally use the Celsius scale. The Celsius scale's abbreviation is the degree sign and a capital C. In the United States, we use Fahrenheit on a daily basis. We will never use Fahrenheit in the lab. We will always use Celsius. When we need to convert from Celsius to Kelvin, we will add 273. C to K, Celsius to Kelvin, goes forward in the alphabet, therefore we add. When we are moving from Kelvin to Celsius, we are going backwards in the alphabet. K to C goes backwards, therefore we subtract. If you look at the Kelvin and the Celsius scale, you'll notice that the increments are the same. But the lowest temperature on the Kelvin scale is 0. We call that 0 absolute 0. That's the lowest temperature that could ever possibly exist. How do we know that's the lowest possible temperature? Scientists have calculated the rate at which things cool and have been able to mathematically calculate that the temperature, all particles of an object would stop totally at negative 273 Celsius, which is 0 in Kelvin. The official SI unit for pressure is the Pascal, capital P, lowercase a. However, we also use two additional units to measure pressure. One is called millimeters of mercury, mm, uppercase H, small g, and the second is called atmospheres, lowercase atm. You may recognize atmospheres from the weather or from diving. You may have heard this term before. We'll learn how to convert easily among these three units later in the year. The official SI unit to measure energy is the joule. The abbreviation for joule is a capital J. You may be more familiar with the unit calorie. That's lowercase cal. We convert easily between calories and joules in chemistry. 1 calorie is 4.184 joules. The unit for volume is a bit tricky because it's called a derived unit. That means that the measurement is taken from the calculation of other measurements. For instance, a cube, the volume of a cube, is length times width times height, three other metric units. The official SI unit for volume is the cubic meter, m to the third power. If you think about this, 1 cubic meter is a really big unit. Something 1 meter high, 1 meter deep, 1 meter long is rather large. So in the lab, we use its smaller relative, the cubic centimeter. There are 1 million cubic centimeters in a cubic meter. How did I get that number? There are 100 centimeters per meter, so you have 100 centimeters in length times 100 centimeters in width times 100 centimeters in depth. Because these numbers are so large, we tend to use another unit on a daily basis in the lab. We use the liter. That's a capital L. Sometimes we use its smaller relative, the milliliter. There are 1,000 milliliters in a liter. It's really important for you to understand that a milliliter and a cubic centimeter are exactly the same thing. Also, you might hear a cubic centimeter called a cc. They do this frequently in the medical professions. You can take any metric measurement and multiply it or divide it by powers of 10 to get additional metric measurements. So the base unit for a metric measurement might be the meter, the gram, the liter, the watt, the second, or the joule. You can multiply the base unit by times 10 and get a decagram. A decagram is 10 grams. A hectogram is 100 or 10 to the 2 grams. A kilogram is 1,000 or 10 to the 3 grams. A decigram is 0.10 grams, or a tenth of a gram, or 10 to the negative 1 grams. A centigram is 0.01 grams, or 10 to the negative 2. And a milligram is 0.001 gram, or 10 to the negative 3. It's easy to convert within the metric system. Most school children learned some type of mnemonic. Mine was King Henry drank my delicious chocolate milk. If you line the first letters of the mnemonic up from left to right, K, H, D, M, D, C, M, and you think about what unit you are starting from and what unit you are going to, it's very easy to convert within the metric unit. So if I wanted to convert from meters to kilometers, meters is in the center of the mnemonic. Going to kilometers would be a movement to the left by 3 spaces. Therefore, I would take my decimal point and move it 3 spaces to the left. So 3.2 meters, the decimal point would be moved 3 spaces to the left, fill in with zeros, and I get 0.0032 kilometers. To convert from meters to millimeters, I would want to go to the right because millimeters is on the right of the base unit by 3 spaces. So I want to move my decimal point 3 places to the right. So 3.2 meters, taking that decimal point and moving it 3 places to the right, filling in with zeros, I get 3,200 millimeters. How do you know which metric prefixes to use? For God's sake, please use your common sense. Which prefix would you use to measure the amount of water in a cup, a pool, or the world? Well, a cup is definitely less than a liter, so I might use centiliters. More commonly, we use milliliters. A pool is a pretty large amount of water, so I might use kiloliters. And the world, I might need to even use a bigger unit for that. There are units that are much larger than kilo, and there are units that are much smaller than milli. And that will be in part 2 of the tutorial. Have a great day. Try some of the problems in the metric review pack.